Friends, welcome to part 2 of our video tutorial on chapter 13. In this part of the tutorial, we'll talk about various issues that a senior technology leader has to deal with when leading or managing an IS function. Now, the first set of issues are related to managing IT service delivery. How exactly IT services, how exactly the information that is a result of those IT services is delivered to users. There are several decisions or trade-offs that a senior executive needs to make. First of all, with respect to equipment location. I think ideally most units, most organizational departments, they would like to have easy access to equipment so that they can fix things and they don't have to ask permission from other locations to do any changes to the infrastructure. But of course this may not be possible, so at some point an executive needs to decide where most of the equipment will be hosted. Should it be hosted at the central office or in some other locations where other considerations such as cost or quality of networking services come into play. So equipment location is one of those trade-off decisions. Then client server allocations. How much processing should be done by clients and how much processing should be done on the server side, because these decisions will have impact on the overall throughput of the system, on the overall hardware requirements. Operating system standards. Of course, it would be much easier if all computing systems within an organization rely on one single operating system. However, it's not always possible because different systems may be more suitable for different applications, and different departments, different organizational units may have different needs. So that's why a decision needs to be made about with respect to standardization or democratization or delegation of operating system selection to different departments and organizational units. Network redundancy. How much redundancy do you need to have in your network? For example, if one line is down, then do you have any other lines to overtake data transmission from those faulty lines? That may be very important for certain industries such as banking, where downtime is very costly and very damaging to the reputation of a company. But in some organizations, network downtime is not that costly, it's not that dangerous. Bandwidth capacity. How much bandwidth do you want your network to have? Again, this may be dictated by the industry or by the company itself or by the nature of strategies or initiatives that the company is pursuing. I remember in my former university when they started pursuing e-learning as one of their central strategies. They quickly realized that they simply didn't have enough bandwidth to accommodate all those online users relying on their network in real time. So they had to expand bandwidth dramatically before they even start thinking about implementing e-learning on a broader scale. Network response time, how fast you want your network to be. Again, for some industries, some companies, speed or network response time is very important, especially when it's something or some kind of where the company relies on applications that need to have real-time access to data. In some industries, speed is not that important. I think a classic example of an industry where speed is not that important is education, where real-time access may not be necessary. And then some decisions with respect to security, privacy, and network access. On the one hand, you want to give people freedom and authority to access the network in any way that benefits their work, their organizational unit. At the same time, by giving people that kind of freedom or authority, you're exposing yourself to a number of risks. As Kevin Mitnick said, one of the most famous hackers, most of the intrusions, most of the security breaches are a result of social engineering, meaning people picking up some kind of CD or USB drive and installing a virus on their computer because the label on the USB drive says salaries of marketing department. So on the one hand, you want people to have that freedom if they need to install something or copy some data, but also you need to understand that creates risks. Again, depending on the company and on the industry, you may or may not restrict people's freedom and people's access to network. Another set of issues that a senior technology leader has to deal with is the so-called green computing. For a number of years, if not decades, information technology has been viewed as a solution to some of the environmental problems that the society on a global scale has developed. For example, I remember there were all those talks that with the help of video conferencing, technologies such as Skype, Organizations across the globe will rely less on physical travel, let's say using airlines, and this is something that will contribute to the environment because airlines, they burn a lot of fossil fuels, and that creates what's the gas name? Carbon monoxide, something like that. Carbon monoxide pollution, something that creates greenhouse impact and contributes to global warming. So basically, there was a lot of hope placed on technology, so that technology will help us preserve the environment. Unfortunately, it looks like those hopes did not materialize. I mean, widespread access to the internet and widespread use of voice over IP technology did not reduce international travel. But also nowadays, there's an increasing realization that even the IT infrastructure itself consumes a lot of energy. For example, I remember reading a study that estimated that if you want to search Google, for one query, and you understand that Google is a huge machine that has a lot of servers, a lot of computers that are linked together. So this Google infrastructure, just to respond to one query from one user, will use as much energy as a kettle, when you boil water, let's say to make tea. So it's and think about all those millions, if not billions, of searches every day that are made through Google and how much energy Google consumes. So there is an increasing push to reduce energy consumption by IT infrastructure itself. First of all, there is a push. So and senior technology leaders, they have to increasingly deal with that. They need to increasingly deal with those expectations of running an IT department in a green, environmentally friendly way. Now, there are several technologies or techniques or methods that have been developed to keep computing green, to reduce ecological impact of computing. First of all, hydroelectric power. If it's a powerful data center, then senior technology leader may think about getting access to ecologically clean power. Power that relies on hydroelectric plant as opposed to burning coal or burning fossil fuel. But again, it's something that is somewhere in the realm of ideology, because some researchers, as you may know, are kind of skeptical about this whole idea of hydroelectric power. They're saying by building those dams and hydroelectric plants, that seem to block rivers or at least restrict water flow, you are also damaging environment because you're basically destroying the natural habitat of fish and other mammals, in rivers. So it's not as clean as some people think it is. I'm talking about hydroelectric power technologies. Virtualization tools where one physical server can be divided at the software level, at the operating system level, into several servers so that hardware is utilized instead of creating like a separate box, separate server for every department. You use virtualization. Thin clients, which means that users have a very small, inexpensive device that doesn't have much processing capacity, and most processing is done on the server side. Now, this is something just like virtualization tools. This is something that allows for more efficient utilization of hardware resources. Then enhanced sleep modes for microcomputers so that electricity is preserved, and also recycling technology waste. I mean, as you may know, it may not be a good idea just to throw a particular piece of electronics, let's say a laptop, to trash, because a laptop, for example, has battery, and those batteries, they have different chemicals like lithium and other components that are very dangerous to the environment. So a lot of the hardware elements of the IT infrastructure, they have to be processed or recycled in a certain way using specific facilities. So that's another area of concern for a senior executive who is concerned about keeping his or her IT infrastructure green. Now, another set of issues that a senior technology leader has to deal with are chargeback systems. Now, chargeback systems, they place control of IT spending with the business managers and enables them to better understand their true IT cost. Now, let me expand on that. IT department in any organization is largely viewed as a cost center. Meaning it's a department, it's an organizational unit where money is allocated. However, this cost center, the IT department, does not generate any revenues, right? It's like a support function. So therefore, there are always those debates like, how much IT services are really worth, how much we should give them money, are they valuable or not, right? So one of the methodologies or strategies that were developed in response to that is the so-called chargeback system. In other words, it allows senior technology leaders to trace usage of IT resources to specific people, specific departments, so that each department can clearly see how much of the overall IT capacity they used and how much they owe to the IT department. So it's about visualizing, explaining the cost of running an IT department, and then distributing that cost of running an IT department in a fair way among different employees, different users. Now, there are various variations of chargeback systems, various types of chargeback systems. But some of the things that can be used to determine how much each department or each specific employee owns to IT are as follows. First of all, IS personnel, on the level of IS personnel or IT employees, time spent and rate for specific skills. So, for example, how much of IT personnel did each of the department use, let's say, on an hourly basis? Computer usage, how much, a particular department used in computer hours, something like that. Disk file space, how much storage capacity is used by each of the department. Number of transactions processed, so how much a particular department loaded the entire system, the entire IT infrastructure. Or amount of computer main memory use, let's say on a particular server or mainframe, or number of users of an application. So I think the most straightforward one is number of users, I think. But of course, some departments may argue, well, we do have a lot of users, but our usage of the IT system is very minor. Therefore, we don't. It's not fair to charge us for most of the cost. So that's why, in addition to number of users, you may take into account other considerations such as actual computer or network usage. Now, a chargeback system is something that is very important, and there are a number of benefits in designing and implementing a chargeback system. Some of the benefits include, first of all, assigning costs to those who consume and benefit from IT. So basically fair distribution of IT costs, controlling wasteful use of IT resources, because if people don't pay for it, if they're not accountable for it, they may be very wasteful when it comes to using IT. Overcoming erroneous perceptions that IT costs may be unnecessarily high. Some departments say, why are you charging us so much for IT? Like, what exactly are you contributing to us? So a chargeback system can clearly show the contribution of the IT department to specific business units. Providing incentives by subsidizing the price of certain services or innovative uses of technology. So, it's basically like a budgeting mechanism, I guess. It's a way to raise money, right? So basically, like every unit becomes like a stockholder, and you can raise money for new applications or new innovative IT uses. The IS department's budgeting process becomes more data-driven. In other words, you don't say like you need to give us X millions next year. This is based on data, on actual usage, on projections based on actual usage. And then encourages line managers to be knowledgeable consumers of IT, because they must directly pay for such support. So they know what they do and how much it costs. So that puts them in a better position to decide how much they want to use IT and how much they're willing or should be able to contribute in terms of the financial resources to the IT function. Now, another important area that a senior technology leader needs to deal with is a service level agreement, or SLAs. Now, service level agreements, or SLAs, they define the client expectations for a specific type of IT service, as well as procedures to follow when these expectations are not met. So, at the most basic level, service level agreement says, look, as an IT department, this is the types of services that we're providing to you, that we're willing to provide, and this is how we provide it, meaning this is the level of quality that we'll use to provide those services. And this is what you can do, if you're not satisfied with the quality of service. So basically, it's like a menu, of what department can do and cannot do. Now, this is very important because otherwise users may have very unrealistic expectations. Every IT department has limited budgets, has limited financial, human, and technology resources. So you cannot be everything to everybody. I mean, you cannot meet everybody's wish and everybody's concern. So, for example, I remember at my university, one of the area of conflicts with the IT department was software installation, because what would happen is that faculty members would usually wait until the beginning of the semester, and then that's when all of them start requesting a particular software to be installed in labs or on their own computers, basically, the software that is needed for teaching. And that's why our IT director, he made a very clear amendment, I guess, to the service level agreement. He basically said, look, we're here to help you with software installation. However, if you need any kind of installation for, let's say, for a specific semester, you need to file a request the semester before that, so that we have plenty of time to allocate, people to do that. Otherwise, what happens is that in the beginning of the semester, all those requests spike, and it creates a situation where everybody's just busy installing software, and there's no personnel to allocate to, other important IT functions such as user support. Some specific things that a service level agreement should include: a simple definition of the services to be provided. Let's say help desk support is one of those services. The names and contact information of IS personnel that users can contact if they need a particular service listed here. Maybe a table listing the services to be provided and their cost. Maybe not necessarily in terms of money, but let's say in terms of time, right? How quickly a particular issue can be addressed, or how much time is needed to address a particular problem. Escalation procedures, who to contact if agreed upon service response is not being provided. Let's say you're asking IT to fix your lab, and nobody's responding, so how can you escalate it? Who can you ask to take care of that? And then sign-off page for all appropriate business clients and their IS liaison preparing the SLA document. So in other words, everybody has to sign this document to show their understanding and agreement of in relation to the service level agreements, meaning what IT can do, how, at what level, and what they cannot do. So this is like an example of an excerpt from a service level agreement. So first of all, you have speed in responding to particular user requests as key performance metric, and then you have different support levels based on problem types, and then you also have different type of problems will have different maximum time periods in which they should be solved. So if it's a very severe problem, then it will be resolved within 4 hours, 95% of the time. 80% will be resolved in 4 hours, and 95% will be resolved in 24 hours. If it's not a severe, if it's a minor issue, then 80% will be solved within 5 days, 5 business days, and 95% will be solved within 15 days. So again, you need to prioritize because you don't have unlimited resources within the IT department, so some things have to be let go. And this is what SLA does. It just creates like a clear baseline or clear set of ground rules that both the IT department and other organizational unit can use to determine what can be done and what cannot be done. Okay, some of the most common services provided by the IT department are some kind of user support or desktop support, troubleshooting, one of the most common requests, consulting, one-to-one consulting, where an IT employee works with one individual, one-on-one, and consults about how to do certain things with the software, for example. Training and education, another common service provided by the IT department, where different workshops are organized. And by the way, those things can save a lot of time and money for the IT department. Instead of doing a one-on-one consulting, you can require everybody to sign up for certain training so that you can save time on your side. Again, in my university, they did the same thing when they rolled out e-learning. They basically said that every faculty is mandated to receive level 1, 2, 3, and 4 training in Blackboard. And Blackboard was the learning management system that we used in our university. So that saved a lot of time, because otherwise all those faculty members, they would start calling the hotline, the help desk to help them with uploading their files, and overall preparing their Blackboard course pages for the new semester. Tool research and evaluation, for example, if you have some kind of need, let's say to do statistical analysis, you can ask the IT department to do some research about the tools available and their prices and their functions. Purchasing, again, once you decide what you want, you may ask IT department to purchase it for you. And then information sharing, formalizing communications between support personnel and end users, as well as across end user groups. Typical sharing mechanisms include the newsletters, web pages, and intranets. So basically, an IT department needs to keep everybody updated. So for example, if the system is down, if there's some kind of glitch, then everybody needs to be informed. If there's a power outage or if there is a system upgrade, everybody needs to know about that through newsletters or web pages. Now, another set of issues is establishing common policies and procedures. Again, going back to this topic of governance, governance or leadership is not micromanagement. It's not about monitoring every employee, what that employee does, and correcting that behavior. It's about creating like a framework within which every user can achieve his or her goals, help the organization achieve its goals without putting unnecessary strain on the IT department. So therefore, a senior technology leader may invest some time into developing those rules and policies, and then educate end users about those rules and policies. For example, there can be a policy with respect to internet usage. What kind of websites can be used during working hours, what kind of websites cannot be used. Now, this is something that will help optimize or improve bandwidth usage and also prevent situations where people go to shady websites and download viruses. Also, maybe there is a policy about software installation. Can users install their software or not? Now, in some organizations, users cannot install their own software. They always have to request IT department so that IT department can take a look at what they're installing. Okay? Again, this is something that can prevent the system from being overloaded and prevent some security issues. So again, what I'm trying to say here is that being a senior technology leader does not mean monitoring everybody. It means developing a set of policies and rules and then inform consistently, being very patient and methodological about informing all the users about this policy. This is what IS governance is. It's not about spying on each individual user and saying, oh, you can do that or you cannot do that. There needs to be a unified set of rules and policies applicable to everybody. Supporting telecommuters. Telecommuters are basically people who work remotely. It's increasingly becoming common, but again, I think people were placing too much hope on these telecommuting arrangements, but then they quickly discovered that although telecommuting sounds good in theory, sometimes it doesn't work well in practice. Now, I think one of the most important problems, one of the most severe problems with telecommuting when people work remotely, let's say over the internet, is communication, because face-to-face communication is the best, the richest, the fastest way to get your message across. And you just may not have this kind of level of understanding when you do it remotely. Also, when you don't communicate face-to-face and when you don't come to office, it's easy to kind of drift, I guess, to get lost. In other words, you stop responding to emails, then you start sleeping at home, then you sleep during the day, then you start working at night, and then the next thing you know, you lose connection with your company. You don't know what they're doing, they don't know what you're doing, and that's the problem of telecommuting. But I think telecommuting can be a good thing if it's used like on a very small scale. So perhaps telecommuting should not be like the de facto standard, but perhaps you can allow your employees to work from home, let's say every Friday or 1 day per week. Now this is something that will boost their morale, give them a bit more freedom, and perhaps improve productivity. But I'm sure if you let everybody work from home, then it's not going to work. I mean, it just most organizations, they have problems enforcing that. I've noticed the same thing happens with online classes. Like some students, they think that an online class is a class where you don't have to study, basically, because it kind of sounds, well, online course, I don't have to come. Well, yeah, you don't have to come to class, but in fact, I would say it's not easier to take an online course. It's much harder because you need to exert more discipline, more focus to kind of keep abreast with everybody, because nobody is watching. There's no peer pressure. There's no instructor pressure to keep you abreast with everybody, right? So in fact, it's much harder, and that's what students don't realize sometimes when they take an online course for the first time. They think online means no studying. In fact, it means studying more than during than if you take a regular face-to-face course. But some organizations, not some, I would say most of organizations, they support telecommuting, where people can log into their systems remotely and work from home or from the location where they're traveling over the internet. Can be a good solution as long as it's not used on a large scale. Another set of issues that people deal with are legacy systems. Now, legacy systems are old systems that organizations used in the past. Now, it may be difficult to abandon those legacy systems because, again, years and years of data and operations have been embedded into the system, and you cannot just say, well, from now on we're going to use this new system. So typically there needs to be some kind of migration procedure where data is copied or somehow integrated with the new system using middleware. But legacy systems is a huge problem, and once in a while you will see job ads for somebody with expertise in COBOL, let's say. Now COBOL is something, it's an outdated language that have been used. I think COBOL was developed in the 60s, if not, or 70s. So it's an old, outdated language, but there's still demand for COBOL skills because of legacy applications. Some organizations are still running systems that rely, at least partially, on those old COBOL, all those old mainframe-based information systems written in COBOL. So legacy systems is always a headache for senior IT executives. Okay, friends, so this concludes part 2 of our video presentation on Chapter 13. Thank you for listening.